converting industrial buildings from 230 volts three-phase to 120/208 volts raises important considerations. Industrial machinery typically operates on higher voltages, making 120/208 volts insufficient for many applications. The lower voltage requires higher current to deliver the same power, leading to increased electrical loads on equipment and wiring. Existing machinery and equipment may not be compatible with 120/208 volts without significant modifications or replacements. Higher current levels can stress electrical systems, increasing maintenance requirements and operating costs. While 208 volts is considered lower in voltage than 480 volts, it can still cause serious electrical hazards if not properly handled. On the other hand, 120/208 volts is considered safer for workers handling electrical equipment in close proximity to machinery. Lower voltage transformers and motors are typically smaller and lighter, potentially reducing installation and space requirements. Modern electronic equipment may operate more efficiently at lower voltages. Also, 120/208 volts is typically used in commercial buildings, so switching to this voltage in industrial facilities located in commercial areas could provide cost savings in lighting and other auxiliary systems. Whether or not 120/208 volts is suitable for industrial facilities depends on specific circumstances, including the types of machinery used and the safety requirements. In general, 230 volts or 480 volts is preferred for industrial applications due to its higher power capacity and compatibility with existing equipment. However, in some cases where safety or cost considerations outweigh power requirements, 120/208 volts may be a viable option. It is important to carefully assess the implications and conduct thorough risk assessments before making any voltage conversion decisions. Let's delve deeper into the arguments against switching to 120/208 volts in industrial facilities. The first argument is higher power requirements. Industrial machinery is often designed to operate at higher voltages, such as 480 volts or 230 volts, to efficiently deliver the necessary power for their operations. Attempting to run these machines on 120/208 volts can result in insufficient power, leading to reduced performance, overheating, and potential damage to the equipment. Secondly, the increased electrical loads are also a significant factor. Lower voltage inherently means higher current to achieve the same power output. This increase in current places a greater burden on the electrical system, potentially overloading circuits, transformers, and other components. The increased heat generated by higher current can also degrade insulation and reduce the lifespan of electrical equipment. The third issue revolves around compatibility. Many existing industrial machines are simply not designed to operate on 120/208 volts. Retrofitting or replacing these machines can be a costly and time-consuming process. Incompatibility can also lead to inefficient operation and potential safety hazards. Fourthly, switching to a lower voltage can lead to increased maintenance costs. The higher current associated with 120/208 volts can accelerate wear and tear on electrical components, requiring more frequent maintenance and replacements. This can significantly increase the operating expenses of the facility. Finally, the safety concerns must be addressed. While 120/208 volts is generally considered safer than higher voltages like 480 volts, it still presents a risk of electrical shock and other hazards. The increased current associated with lower voltage can actually increase the severity of electrical shocks in certain situations. Now, let's examine the arguments in favor of using 120/208 volts in industrial facilities. Firstly, increased safety is always a priority. Lower voltage systems are generally considered safer for personnel working with electrical equipment. The risk of severe electrical shock is reduced, which can improve overall workplace safety. Secondly, reduced equipment size and weight can be an advantage. Lower voltage transformers and motors tend to be smaller and lighter than their higher voltage counterparts. This can simplify installation and reduce space requirements, which can be particularly beneficial in older facilities with limited space. Thirdly, improved efficiency can sometimes be achieved. Some modern electronic equipment, such as lighting and control systems, may operate more efficiently at low voltages. This can lead to energy savings and reduced operating costs. Fourthly, cost savings in commercial areas can be realized. Industrial facilities located in commercial areas may benefit from using the same voltage as surrounding businesses. This can simplify the electrical infrastructure and reduce costs associated with transformers and other equipment. The suitability of 120/208 volts for industrial facilities ultimately depends on the specific application. For heavy-duty machinery requiring high power, higher voltages like 480 volts are generally preferred. However, for smaller equipment and lighting systems, 120/208 volts may be a viable option. It is important to carefully consider the power requirements, safety concerns, and compatibility issues before making any decisions about voltage conversion. A thorough risk assessment is essential before making any changes to the electrical system of an industrial facility. This assessment should identify potential hazards and evaluate the effectiveness of safety measures. It is also important to consult with qualified electrical engineers and contractors to ensure that the voltage conversion is done safely and in compliance with all applicable codes and regulations. When evaluating a potential voltage conversion, consider the long-term costs and benefits. While there may be some initial cost savings associated with using 120/208 volts, the long-term maintenance costs and potential safety risks may outweigh these savings. It is important to conduct a thorough cost-benefit analysis to determine the most economical and safe option.